Yeah. Okay, so next unit is on acceleration. Okay. By the end of this lesson, you will be able to define acceleration mathematically and conceptually, know when an object is undergoing acceleration, make a distinction between velocity and acceleration, and make an acceleration versus time graph from a velocity versus time graph. All right. First off is the definition of acceleration, and that is the rate at which velocity is changing. The rate at which velocity is changing. And so that's like the textbook definition. A little bit more common way to say this is how quickly you are changing your speed. How quickly you're changing your speed. Okay. The variable for acceleration is a lowercase a, and the equation is the change in velocity over change in clock rating or time interval, which can be expanded to change in velocity is final velocity minus initial velocity over final clock rating minus initial clock rating. Good with that? The unit, so check this out. What is the unit for velocity? Meters per second. And what is the unit for time? Seconds. The unit for acceleration is meters per second per second. Now, you can simplify that mathematically by saying meters per second squared. Okay. But oftentimes the follow-up question to that is like I can visualize a square meter, but a square second, what does that look like? Don't try. This is just simplified. Conceptually, it's understand it like this: meters per second, or for every 1 second. A unit of acceleration that we might have a little bit more be able to relate to a little bit better would be miles per hour per second. Okay, I'm never going to have you calculate that. I'm just so if we had an acceleration of 5 miles an hour per second, what that means is every second that goes by, you're changing your velocity by 5 miles an hour. So it would be like 0, 5 miles an hour, 10 miles an hour, 15 miles an hour, 20 miles an hour. Every second that goes by, you're changing your velocity by 5 miles per hour. But we're never going to use miles an hour. We're going to use meters per second. Good with that? Okay. All right. Questions there? First question. So cruise control, some people don't know what that is. That is a feature that locks your speed in. Like, hey, I want to go this speed. And then it automatically maintains that speed. Okay, so give that one a shot. Thumbs up when you have a guess. Tell your neighbor. Tell them why.
You're not changing it. Oh my gosh. There's no math to be done.
Just 40 divided by 20.
Oh. Wait, okay, I accept the fee.
It's 20. I think there's 20 seconds. That's seconds.
Correct answer is YA. Okay. Acceleration is the rate at which velocity changes. Okay. There is no change. Okay. So acceleration is 0. Here is a big point of confusion. Understanding what velocity is and understanding what acceleration is. Oftentimes when students come in here, those two terms are muddled together. It's my goal today to give you multiple examples of how they are drastically different. They're not the same thing. Okay? So here you can be moving and have no acceleration if your velocity is not changing. Good with that? And you can be moving fast, but if it's not changing, no acceleration.
Stop influencing my answers.
Thumbs up when you have a guess. Converse. Tell them why you think so.
It doesn't. Acceleration changes velocity over time. So it's changes direction down.
Right.
Acceleration goes direction.
You're right.
You can be going the same direction. You're not taking it. Yeah, that is. You can do that, changing your velocity. So if you change direction, yeah, I just because that's plus or minus is if you're going to wait, or if you're going away. I would not put money behind it. Right now, it's
Okay, correct answer is. Okay, so if you are slowing down, does that change your velocity? Yes. Okay, so A is obvious. B, yes. Now, velocity communicates two things: how fast you're going and direction. So if you change your direction, is that changing velocity? Yes, that changes velocity. So correct answer is E, all three, A, B, and C, is considered in physics a experiences acceleration. Okay? Next question. Thumbs up when you have a guess. Tell your neighbor. Tell them why.
Oh yeah, no, let's change. Let's change percent. Yeah, I read it wrong. It's 75. Yes, it's 5. I was gonna say. I was just kidding. Just gonna say, hey, no, no, but I just did that. I read it when you overcomplicated. Oh my gosh.
Correct answer is
B.
B.
Yes.
B.
Yes.
The car's going way faster.
That's a greater acceleration.
Okay. The bike is changing its velocity more in that same amount of time than the car did. Okay. So, is it possible for something to be moving slower and have a greater acceleration than something that's moving faster? Absolutely. Velocity and acceleration are two distinct things. They are not the same. Okay. This is another example. Good with that? Okay. Next question. Have a conversation. Correct answer is?
C.
Correct answer is C. All right. You could do this mathematically. Okay. Initially, so she starts at rest, so your initial velocity is 0. So you have 2 meters per second squared is equal to your final velocity, what you're looking for, over 6 seconds. So 2 times 6 is 12. That's mathematically. Conceptually, here's the idea. Every second that goes by, you change your velocity by 2 meters per second. Okay? So you start at 0 and go 0, 2 meters a second, 4 meters a second, 6 meters a second, 8 meters a second, 10 meters a second, 12 meters a second. Over 6 seconds, you change your velocity by 12 meters per second because you change your velocity by 2 meters a second every second. Good? All right. Everybody get out your speedometers. Everybody get out your speedometers. Show me speeding up with a constant acceleration. Show me speeding up. What would your speedometer look like if you're speeding up with a constant acceleration? Okay. Nope. No. Okay. So constant acceleration, that could be this. That could be this. So long as it's moving constantly, that is all that you care about. Okay. All right, show me speeding up. Actually, work on these last two. Speeding up with a constant acceleration and, sorry, with an increase in acceleration and speeding up with a decrease in acceleration.
Why did you do that? You guys brought me a big bag. I remember that. Big bag. Remember that?
No, oh, I don't know.
Like literally, I put like this. I did some work and I said no. No, like he.
Yeah, I'm thinking going backwards.
He kept he swore on
Why
me.
was I going like?
Oh, I knew what your record was for. My next bench was.
I mean, that makes
Oh,
sense.
God.
No, that makes no sense.
This is my God.
I forgot to ask who lost.
Or at least
They asked for 45 to
check
I would have said 6. Yeah.
I
I was just too road to that one.
Speeding up with a increase in acceleration, looks like. Good with that. Speeding up with a decrease in acceleration. Okay, I've seen a lot of stuff over the years. You get stuff like this, like no, speedometer doesn't do that, or like, but is that speeding up? It's not speeding up. Okay, speeding up with a decrease in acceleration. This really nails the difference between velocity and acceleration. You're increasing your speed the whole time, but the rate at which you're increasing your speed decreases. It would look something like this. Okay, where you're getting faster the entire time, but the rate at which you're getting faster is slowing down. Okay, and if you think about it, this is actually how your car, if you punched it, this is how your car speeds up. It's like, run. It's easy to go from 0 to 20. It does that quickly, but then going from like 70 to 80, that takes a lot longer amount of time. Does that make sense? Okay. Next question. Tell your neighbor.
I do believe
Why is B?
Correct answer is? Correct answer is B, 5 meters a second. Okay. Your speedometer looks like this. 1 Mississippi. By the time you end with the IPI, you're at 5 meters a second. Good with that? Same scenario, follow-up question. It's how far versus how fast. Thumbs up when you have a guess.
Stop influencing other people, Alton.
Tell your neighbor and tell them why you think so.
Why would it be like, when it's per second?
I don't accelerate. You can't just start fighting.
You go 5 meters. So in 1 second, you can be a 5.
Yeah, but
Don't
you're
start that fast.
You're in the first second. You're in the first second.
So it has to. Wait, in the entire first second, that will travel 5 meters. How far will he travel in the first second?
Inside
So
first
in
second.
1 second, he travels 5 miles.
From 0 to 1. Not at 1. From 0 to 1.
0 to 1, you're traveling 5 meters.
Okay.
5 meters is what?
No, you're not.
Correct answer is? All right. In order to go 5 meters in 1 second, you would have to be traveling at 5 meters per second for the entire 1 Mississippi. Does that make sense? In order to travel 5 meters, you would have to be going 5 meters a second for the entire time. But your speedometer didn't look like this. It looked like what? 1 Mississippi. By the time you end with Ippy, now only then you're going 5 meters per second. Okay, so the correct answer is less than 5 meters. Okay, now later on, I will show you the equation that will tell us exactly how far you would go. But I wanted you to get to you're thinking the difference between, okay, what is acceleration, what is velocity, how does that look like with displacement? Okay, good with that? Okay, velocity versus time graph. The slope of that is rise over run, delta y over delta x. What is on the y-axis? Velocity. So change in velocity over what's on the x-axis? Change in time. What is this? This is acceleration. Okay? The slope of a velocity versus time graph tells us the value of acceleration. The slope of a velocity versus time graph tells us the value of acceleration. The slope of a velocity versus time graph tells us the value of acceleration. This is the same relationship that we had between position versus time graph and a velocity versus time graph. The slope of a position versus time graph tells us the value of velocity. The slope of a velocity versus time graph tells us the value of acceleration. It's the exact same relationship. It's just a different measurements relating. Okay? Good with that? First question. Thumbs up when you have a guess. Tell your neighbor. Tell them why.
Acceleration versus velocity versus
Correct answer is C. Okay. The value of, mathematically, the value of the slope, this is zero slope, therefore you have zero value of acceleration. Okay. The story behind this is you're moving at a constant velocity in the positive direction, meaning your acceleration is not changing. Sorry, your velocity is not changing, therefore you have no acceleration. Okay. Next question. Thumbs up when you have a guess. Converse.
Why is it Wednesday? So it's not. But it's changing. So it's changing. Oh wait.
Correct answer is? Correct answer is A. You have a negative constant slope, therefore you have a negative constant value. Okay, you're slowing down in the positive direction. Now, here's a little tip. Last chapter we said that velocity versus time graphs will always be straight lines, not horizontal lines, but straight. Therefore, acceleration versus time graphs, because of that limitation, are always going to be horizontal lines. Okay, so really what you need to make a distinction between is a positive, negative, or zero. Good with that? Okay, these will always be straight lines, therefore these will always be horizontal. Okay. Tell your neighbor. Correct answer is B. Beautiful butterflies. Okay, the motorcycle reaches the 50 miles an hour sooner than the truck does. Tell your neighbor. Tell them why you think so. Correct answer is A. Everybody go with that? You're slowing down quickly. It takes longer to speed up. Same scenario. What is the acceleration versus time graph? Thumbs up when you have a guess. Tell your neighbor. Correct answer is good. You have a, oops, sorry. Here you have a steep negative slope. You have a positive, not so steep slope. Good. Last question. Have a conversation. Tell them why you think so. Correct answer is? Correct answer is C. They have parallel slopes. Okay. It doesn't matter which one's starting faster or ending faster. What matters is how quickly they're changing their velocity. Good with that? We have a pre-quiz due tomorrow. Yep. So